The sixth element on the periodic table of elements is carbon. This is North Teaches Science with me, Mr. North. This is another physical science edition of my lecture videos. And today we're going to talk about solutions. So by the end of this video, you should be able to say to yourself, I can determine properties of solutions and solubility based on the solubility curve. All right, we already talked about what a solution is in a previous video about different types of mixtures. It is a type of mixture, and that means there's two parts to a solution, either the solute or the solvent. The solute is the part that is being dissolved, or the part being dissolved. It is, for example, sugar or salt when you apply that to another liquid. The solvent is the part doing the dissolving, and water is considered a universal solvent. Almost everything can be dissolved by water. There are things that cannot. Can you think of something that cannot be dissolved by water? Maybe you said oil. That's a good one. But other types of solvent other than water are like alcohol. Solubility is the ability for the solute to dissolve in the solvent, and that is determined by the attraction between the solute and the solvent. So the factors affecting solubility are like polarity. I know I say it weird, get over it. So substances can be either considered polar or nonpolar. If they are polar, that means they have like a positive and negative end or a north or south pole to it. And likes will dissolve likes. So a polar will dissolve another polar substance. A positive nonpolar would dissolve a positive nonpolar, all that stuff. So that if you get the sense of the picture over here now, polar bear, water's polar, if you don't get it, it's okay. It's over your head. Another thing is temperature. If you increase the solvent's temperature, the thing that's doing the dissolving, you can increase solubility and increase how much can be dissolved in there. That's why when you're making, say, Kool-Aid, you need to use hot water to dissolve all the sugar in all the Kool-Aid mix, so you don't have that sugary stuff right at the bottom. The last class that's really sugary. Yeah, if you just increase the temperature, you won't have to have that. There are three levels of a solution. You have being a saturated solution means containing the right amount of solute in the right amount of solvent at a given temperature. This is like having the perfect glass of sweet tea. I live in the South. We drink sweet tea. Unsaturated solution means not having a lot of that solute in the solvent. There's not enough. We think of that down here in North Carolina as having weak sugary tea that tastes nasty. You northern people, I'm sorry, sweet tea, not unsweet. And then the third one is called supersaturated. It means having a lot more solute in there than it normally can at a given temperature. If we're going back to the sweet tea thing, where your tea is like syrup. I've had that before too. We like a perfect glass of sweet tea. All right. Now, electricity and solutions. Some solutions are classified as being electrolytes and some are classified as being non-electrolytes. An electrolyte is a solution that can conduct electricity. So like salt and water. Salt and water. If you haven't ever looked at Gatorade has a lot of salt in it. The reason why is because Gatorade is supposed to replenish the salt in the water that's coming out of your body when you're sweating. Non-electrolytes are solutions that cannot conduct electricity, so like sugar and water will not conduct electricity. Solutions can be diluted or concentrated. A diluted solution is like a watered down or a weak solution. You can see that here. You do that by just adding water to a solution. Concentrated solutions are strong solutions, like over here. You usually start with a concentrated solution and then dilute your way down to the diluted one that you want, type of solution you want. Now with solubility, we also have something, we know how temperature is going to affect certain chemicals, and we have this placed on something called a solubility curve. And the solubility curve shows how temperatures affect solubility of the solutes. So if you can see in here, if you look at this solubility curve, you have grams per 100 grams of HO2. So 0 grams to 150 grams. And all of it's in 100 grams of H2O, which is water. At the bottom, you see the temperature, and each line is labeled with a different element. This one up here, that's Ki, while the one right here, it's NH4Cl. We'll get into why it looks like that with the different element symbols in a couple videos. So let's use the solubility curve and answer some questions. So we have the solubility curve over here. It says what compounds, there's an S, shows a decrease in solubility from 0 degrees Celsius to 100 degrees Celsius. So a decrease is your thing. If the line's going up, it's an increase. If the line's coming down somehow, it's a decrease. So you have to look across all the lines. And I see NH3 right here. It's sloping down. And then if I look really close, I see another one. Ce2 parentheses SO4 3. And those are the only two that are decreasing as temperature increases. All right, I'll switch colors for this next one. Let's do blue, dark blue. It says which salt is most soluble at 10 degrees Celsius. So you go to the bottom of the chart where it says 10 degrees Celsius and you follow it up. It says most soluble. So we want the last line we would hit as we go up. So as we go up, we keep hitting lines, It may be this one, but oh wait, here's the last one, which is Ki. It's the topmost line. All right, switch colors. I'll go to purple this time. This time says which salt is least soluble at 20 degrees Celsius. That means at 20 degrees, we're going to go up until we hit and then look for the first line. We hit the line here, we follow it over, and we see it's KClO3. I hope everyone's following along right now. If not, pause the video, rewind it, look at it again. Maybe it will come to you. And then last one on this page, it says which salt, that would be anything up here, shows the least change in solubility. What that means is we're looking for a line that's almost flat. Looking for the flattest line. If we look here, I see this line right here. That's not really increasing much, and that's NaCl, also known as table salt. All right, let's do the last two questions. Number 5 says, how many grams of potassium chloride, KCl, can be dissolved at 80 degrees Celsius? So what you're going to do, you're going to go to 80 degrees Celsius, and you're going to follow up 80 degrees Celsius till it crosses the KCl line, and that happens here. Then you're going to go directly to the left. You want to follow it directly to the left. And you're going to see that it's at 50. So it's 50 grams. Always have your units there. Units are very important in science. I'm going to change my colors back, my color again. We're going to go back to red. It says at 30 degrees Celsius, 90 grams of sodium nitrate, NaNO3, is dissolved in 100 grams of water. We're trying to figure out if the solution is saturated, unsaturated, or supersaturated. So the first thing we're going to do, we're going to plot our point. 30 degrees and 90. So we go up 30 degrees until we reach where 90 is. 90 is here. 30 comes up here. They intersect right here at this point. We also need to look for our line, NaNO3, which is right here. Now here's how it works. Saturated is on the line, unsaturated is under the line, and supersaturated is above the line. And this is when you're looking from bottom up. So if we look at our point here compared to the NaNO3 line, our point is below the line or under the line. So it's unsaturated. If it was on the line, it would be saturated. If it was over or somewhere up here, it would have been super saturated. But this is unsaturated. It means you can have more NaNO3 at that temperature. And that's a little bit about solutions. I hope you learned something today. And this is Mr. Norris, and I am signing out of this video.